On the top of the screen is CFS Command Studio. On the bottom is the PicoZ console running NASA's Core Flight System, or CFS, with live messages. For this demo, both the hardware command validation and AES GCM decryption paths start enabled. First, I'll show hardware command validation. Here I'll send a CFE ES stop app command targeting non-critical app. With validation on, this command is allowed. On the console, you'll see a few green messages showing that validation passed and the app stopped successfully. Now I'll send the same stop app command for critical app. With validation enabled, this one is blocked. You'll see red rejection messages on the console showing that the validator rejected the command and the critical app keeps running. So with validation on, valid authorized commands are processed normally, while any unauthorized commands targeting critical app are stopped. Next, let's look at decryption. The commands we've been sending so far have all been encrypted. You can see that the encrypt TC payload box is checked. With decrypt enabled, these encrypted commands have been going through normally. Now I'll disable the decryption pathway on the PicoZ and then send another encrypted command. With decrypt off, the command is blocked and never ingested. The console shows red error messages indicating that the encrypted frame failed to ingest. To show the contrast, I'll uncheck the encrypt TC payload setting and resend the same command in plain text. With decrypt disabled, plain text commands still succeed, and you'll see normal green confirmation messages again. To recap, with hardware validation on, any unauthorized commands were blocked from executing while approved operations were allowed to pass. While hardware decryption was on, encrypted traffic could be ingested. Once we turned it off, and encrypted messages no longer made it through, leaving a red ingest error on the CFS console instead.